Hi everyone, welcome back. So Codeforces question for today is a strange partition. It is a deep 2A problem, 900 rated. So we are given an array of length n and an integer x. We have to perform the following operation as many times as we would like. In this we can replace two adjacent elements of the array by their sum. So if the array was initially this, in one operation we can add both the adjacent elements and replace it with their sum, that is 6 plus 9, 15. If we replace the last two elements, or if we replace the first two elements, then 9 and 9. So we can do this operation any number of times. Now beauty of an array is defined as sigma 1 to k, where k is the length, ceiling of element divided by x, that is the integer which we were given, that's math.ceil, element divided by x, means we are rounding up the number divided by x. So we have to perform this for divided by x and take the sum. So beauty of array this, where x is equal to 3 will be given by this 4 divided by 3 method seal, then this. So this will be give us 1 point something, so 2, then 3 point something, then 4, and this will give us exactly 2. So 2 plus 4 plus 2 is 8. So this is the beauty. Now our task is to determine the minimum and maximum beauty we can get by performing some operations any number of times we can perform these. We have to find out the minimum and maximum beauty we can get. So this is the question. So this tests our math skills. How shall we do this? What shall we do? First of all, one thing we see is in summation we are doing ceiling. So we can see that we get some remainder when divided by x, and that remainder will be converted to a whole number. So if a remainder is 1 and x is 3, it will get converted to 3. If it is 0, then it won't be converted, it will remain 0. So for maximum, what we will want, we will be liking the most number of times we get something as a remainder instead of 0, so that it gets sealed, rounded up, and we get increment in our sum to get the maximum. And for minimum, we will be wanting our remainder to be 0 the most number of times. Now what operation we can perform? We can add adjacent numbers. So what will adding these numbers do? So suppose we have x is equal to 5, so we get a remainder from 5, and suppose remainder here we get for one digit we get a remainder 2, and for the adjacent digit we get the remainder 3. Now if we have to make that maximum, what will we want? We will like that let the 2 remain 2 and the 3 remain 3. So when we will do our beauty operation, it will be converted, both will be converted to 5, and we will get the maximum result. Because if we add 2 and 3 adjacent numbers, so the remainder at last would be 0, and 2 and 3 will be converted to 5, and division it will get only 1. So the sum will not increase. For minimum, we will want that adjacent numbers be added, because addition will reduce the remainder. So this is the basic trick in this question that we have to do. For maximum, we just have to divide by x and get the ceiling, because we do not want our remainders to be added so that they don't get reduced. And for minimum, we want the sum of all. We want all the remainders to be added, and at last we will do the ceiling so that we get the maximum or minimum result. So moving to the solution, now it is very easy. We have to find out the trick. We take t number of test cases, then we take n, then x. We have kept a variable sum and a variable max. Sum is to for find the minimum, and max we will directly keep on finding out, that is dividing and getting the ceiling. We have put a loop on n. We take n integers input is in a, Now max will be directly getting the ceiling of the number a divided by x. We have multiplied it by 1.0 to convert it into decimal. Otherwise it would have been integer division, which would have given us a floor value. And then in decimal we have applied method ceil function, which rounds it up. We have taken long because our answer may go out of the integer range. So after this we add it to the max, because this is what the maximum is. We want the remainder to be sealed up for every number, rounded up for every number. And for minimum we keep adding all the numbers. Now at last, for minimum we have to do the sum divided by x, because we have added all the numbers. Remainders would have been added for all the numbers. We just divide it by x and do the ceiling. That would be our minimum, and maximum we have already calculated. So this was the simple solution for this question. I hope you guys would have understood the trick. Thanks for watching the video. Enjoy, have fun. Bye bye.